Hello students, welcome to Inside Physics. Today we will see some more problems on electrostatics which are very important for the NEET exam. Here is one. The bob of a simple pendulum has mass of 2 grams and a charge of 5 microcoulombs. If it is at rest in a uniform horizontal electric field of intensity 2000 volts per meter, at equilibrium, the angle that the pendulum makes with the vertical. So here there is a simple pendulum which has a bob which is tied to a string. So that simple pendulum has put in an external electric field of intensity 2000 volts per meter. So the bob has a mass of 2 grams and it is carrying a charge of 5 microcoulombs. This is the data that we got. So it is asked to take gravity value as 10 meters per second square. Now here we will picturize this. Whenever a simple pendulum is in no field, there is no external field. So here we applied the external field in this direction. Let us assume the external field applied is in this direction. So it is already having a charge of 5 microcoulombs. So if it is 5 microcoulombs means it is obviously positive charge. So the electric field is from left to right direction. That is, here there will be a positive plate and there will be a negative plate. So obviously the pendulum will be attracted towards the negative charge and it makes some angle with the vertical. So this is the angle that actually asked in the problem. How to get this angle? So by symmetry we know this is the charge on the bob and this is the electric field applied in this direction. So what is the force acting on the bob? It will be EQ. The charge on the electric field applied is E and the charge is Q. So the force acting on the charge Q is F is equal to EQ. Now this force will be towards this side. Okay. And the tension in the string obviously will be in this direction. So the weight of the bob will be exactly downwards. The weight always pulls downwards towards the center of the earth. And here if you observe the tension in the string is making an angle with the theta. So we can divide this tension which is in this direction into two components. This is one component and this is another component. So I have divided the tension into two components, vertical component and horizontal component. As per symmetry, if this is theta, this is also theta. So this is T cos theta and this is T sin theta. We know how to divide into components. So if this is in balanced condition, what is exactly given? At equilibrium. Equilibrium means the net force on the bob is 0. So the forces in the horizontal direction and in the vertical direction must be balancing each other, right? Then only the bob will be in equilibrium. If these are balancing each other, we can write T cos theta is equal to mg and T sin theta is equal to EQ. So by these two we can write that T sin theta by T cos theta is equal to EQ by mg. So T gets cancelled. So here we will get tan theta is equal to EQ by mg. Now we will substitute all the values E, Q and M and G in this relation. So for that, what we need to do? We need to take the values and apply in the formula. So we know that what is E? E is already given as 2000 volts per meter and what is Q? Q is in microcoulombs. So we need to change it into coulombs. Mass is nothing but 2 grams, which is 2 into 10 to the power of minus 3 kg. And gravity, we all know, asked to take as 10 meters per second square. So we have got all the data E, Q, M, G. So substituting in this formula, we will get, you can do the mathematical calculation, and it is left to you. The value will be coming as 0.5. So when you substitute E, Q, Mg values here, you will get the value as 0.5. That implies, what is tan theta here? Theta is equal to tan inverse of 0.5. So if tan theta is equal to 0.5, theta is equal to tan inverse of 0.5. The answer is D. Okay. Here we see the second problem. See, determine the electric dipole moment of the system of three charges placed on the vertices of an equilateral triangle as shown in figure. Here is the given figure. There is an equilateral triangle which you can name it as A and B and C. At the three vertices there are three charges placed, minus 2q, q and plus q. If you understand this diagram, all the internal angles of this equilateral triangle are 60 degrees, we know that. So if you redraw this diagram, see, I will take this as, see, all what I do is, okay, so I will take minus q here, and plus q plus q. The same diagram given in the problem. Here minus 2q is divided into minus q and minus q. So there are two individual charges which are summed up and shown here. So the dipole moment, if this is a dipole considered as minus q plus q, two opposite charges separated by a distance is always called a dipole. So here this is also a dipole. Dipole moment will be always from negative to positive. It is opposite to the electric field direction. So this is always taken as negative charge to positive charge. So the electric field, if the electric field is taken in the direction opposite to the dipole moment. So dipole moment is same here, and this is also same. What will be the resultant dipole moment direction? So he is asked to calculate the resultant, determine the electric dipole moment of the system. This is a system. So the resultant will be in this direction. Okay. So how to get this resultant? The angle between the two dipole moment vectors is 60 degrees as shown here. Here the dipole moment direction is also shown in this way. The resultant will be exactly in this direction, which is taken as P resultant. So the resultant, the system dipole moment can be calculated as root of p square plus 2 into p cos 60 degrees as per parallelogram law. Here we will consider this as p square plus p square, and cos 60 you all know that is 1 by 2. So here 2 gets cancelled. This will come to be 3p square. Right. So the resultant, then the dipole moment of the system is nothing but root 3p. We all know that p dipole moment is nothing but any charge of the two charges into distance between the two charges. It is always L. Distance between the two charges is L. So here we can write root 3 QL. And what is the direction of the resultant dipole moment? If this is considered to be y-axis, that means the unit vector is j cap, and this is x-axis. Along this there will be a unit vector I cap. So in this way we can consider this is j opposite to the z direction, that is minus j cap. We also need to give the direction in vector form. So this has come to be minus root 3 QL j cap. So this is what the answer. Answer is C. Okay. Here we will see the third problem. When an electric dipole P bar is placed in a uniform electric field E bar, then at what angle between P bar and E bar the value of the torque will be maximum. So you all know, whenever a dipole is placed in an external electric field, so the dipole will be experiencing a torque on it. So this is attracted, the negative charge is attracted towards the positive plate, and there will be attraction towards the negative plate of the positive charge. Two equal and opposite charges separated by a distance is called a dipole. So the torque acting on this dipole is represented by P bar cross E bar, the cross product of dipole moment and the applied electric field. This is nothing but Pe sin theta. This is the derivation we already did in the class in electric charges and fields. So this is what the relation between the electric field and dipole moment vectors. So the torque will be maximum. Now for what angle the torque will be maximum? We all know that the sine value will oscillate between -1 and 1. If you put 1 here, we all know the torque will be maximum. And for what theta values, sine will be 1. Here in these four options, sine 90 will be 1. So for an angle of 90 degrees between P bar and E bar, the torque will be maximum. So the answer is A. Here we will see the fourth problem. A sphere encloses an electric dipole with a charge plus or minus 3 into 10 to the power of minus 6 coulombs. That means a dipole has a positive and negative charge, which is given as 3 microcoulombs. What is the total electric flux across the sphere? So this question can be answered by using the concept of Gauss law. Gauss law says the total electric flux coming out of any closed surface is equal to 1 by epsilon naught times the total charge enclosed inside the surface. This is what Gauss law says. The total electric charge enclosed inside the sphere, that means surface. So if you imagine a sphere like this, and there is a dipole inside it, there is a dipole having a charge 3 into 10 to the power of minus 6 and minus 3 into 10 to the power of minus 6. Here there is a negative charge and there is a positive charge. Three equal and opposite charges, two equal and opposite charges separated by a distance is called dipole. So the flux coming out of this entire sphere is 1 by epsilon naught times the charge enclosed inside the surface. So here what is the total charge enclosed inside the sphere? 3 plus 3 into 10 to the power of minus 6 minus 3 into 10 to the power of minus 6 by epsilon naught, which is equal to 0. So there is a positive charge, there is a negative charge. If you add these two, that will become 0. So if Q is 0, flux coming out of this sphere will be 0, and the answer is B. Now we see the fifth problem. Two parallel infinite charges with linear charge densities minus lambda and plus lambda are placed at a distance of 2r in free space. What is the electric field midway between the two line charges? We already seen this how to calculate the electric field due to an infinite current carrying conductor, which is a line charge, given as a line charge and of infinite length, and it is having a linear charge density. What is linear charge density? It is always given by lambda is equal to Q by L. So if I consider two linear charges like this, which is having a positive charge, that means charge density lambda, and which is having a negative charge, that is this is plus lambda and this is minus lambda. So obviously the plate A, if you consider this not plate, this is the conductor A, this is conductor B. If this is the electric field due to this current carrying element is EA, that is in this direction, and the electric field due to this line element B is also in this direction, same direction, EB, because the field will be converging towards the negative plate. It always starts from positive plate, ends at a negative plate. So the distance between the plates is given by 2r. So exactly what is given at the midway between the two plates, what is the electric field? So exactly midway means if you take a point here at the midpoint, it is a distance r from this plate and it is a distance r from this plate, right? So what is the electric field due to this plate? Electric field due to plate A is nothing but, from Gauss law, the application, we can know that the electric field calculated is 2 pi epsilon naught r. Okay, so if you take the modulus of this, so we are getting only having the value. So because both the electric fields are in the same direction, and the electric field due to line charge B is nothing but same, because the charge density is same and the distance of the point from this plate is also same. So the value will be same. So what is the net electric field at this plate due to both the plates? Means we need to add the two electric fields because they are both are in the same direction. So by adding these two, what we will get? The net electric field is equal to mod EA plus mod EB. We will get, by simple adding, this will be lambda by pi epsilon naught r, because 1 by 2 will become 1, and by adding this lambda by pi epsilon naught r, this is the resultant electric field exactly midway between the plates. So the answer is B. So we will conclude this session of NEET problems. We will be having some more interesting problems in the next video.